Yes, sir.
Good. Okay. Okay. So recall last time we had been doing things like a span of a vector and a set of vectors, and we showed what is a basis vector. So we had discussed. So I'll just we said two things last time. That span of a set v1, v2, dot 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 vk is nothing but the set of, and we had shown that this is true geometrically as well. So the span of k vectors is the sum of the linear combination of each of these vectors, right? So it's the sorry, it's not sum, it's the collection of the linear combination of all these vectors. So we had seen that if we have a few vectors, we can always take their linear combinations and they end up making a plane. They end. So if we have a few vectors, we can always take their linear combinations and they end up making a plane in k-dimensional space, depending on the number of vectors. We saw these things. I hope you all recall. So if you have k independent vectors, then you can make a k-dimensional space out of it. And we showed a thing called basis, which was the minimal set that spanned S.
A vector space, is it as S is a vector space?
So please go back and look. It's a subspace, and subspaces are vector spaces also,
Oh, okay,
because it's
fine,
a
fine.
part of a vector space. And vector spaces and all is not required. You just need to know what is a subspace. And what we have discussed, what is a vector space and the fundamental abstract algebra concept of it, but we are not going to go into details of that. We'll just see it in Rn, or maximum some cases in Qn. That is rational. We had shown last class that it was over set of the complex numbers or real numbers. So today we'll only be dealing with real numbers. That's primarily what we'll be dealing with, and we'll start with a small problem to recall things from last class. The problem is sum of two subspaces, say x comma y, are subspaces of a vector space, say f to the power n, where f is the field of numbers and it's the n collection of n numbers, if you recall, right? So if you have n numbers, these are collection of, this is a subspace belonging to that. So these are x comma y are subspaces of a vector space. Now my question is, for example, you can have a line and a two plane if these are, which are subspaces of R3. Just an example. So what does, if you want to have an intuitive view of things, and if you have not followed last day's class, so one plane passing through the center will always be a subspace. We discussed this last time. And one line, say these two are two subspaces, right? So this is x, say this is y. What is the sum of these two subspaces is what we try to understand. So is the problem statement clear to everyone? Any questions?
Yes, it's clear.
Okay, so what does it mean to add two subspaces? Their subspaces are collection, they're sets. So how can you add them? So to add them, we define it that we take one element from x and one element from y, and we add them. And that full set is, we'll say, is sum of those subspaces. Is it clear? One element from X and one element from Y, and we'll add them, right? What we are told to show is the dimension of those two subspaces is equal to the summation of individual dimensions minus the intersection of these two spaces. Okay. Any ideas how will we go about showing this? How to start off with it? There's a hint. Last
We'll
time we
take any
stopped.
two.
Go ahead. I'll give you the hint first, then you can tell. Last time we discussed, if you recall, that a span, the dimension of the span is also equal to, or the dimension of the subspace is equal to the number of basis vectors, right? Just now I intuited that if you have k spaces, k vectors, they can span a k-dimensional space, independent if they're independent, right? So number of basis vectors would determine this, the size of the subspace, right? So that's the hint. Any doubts? I hope you have followed gone back and done the homework, as in revised things at least, right? I can use those concepts, right? So the number of basis vectors is equal to the dimension of the subspace. So you're told to find a dimension. You have to show the dimension of this union set or the sum set is same as this. So any ideas?
So we'll find a minimal set of independent vectors and see
Okay.
what is that dimension.
Okay, that's a good idea. Let us start. So, but which one to start with? So, do you agree that X intersection Y? So, S intersection Y, the basis vectors of S intersection Y would both belong to X and Y, right? These are the basis vectors of S intersection Y, right? Do you
Yes.
agree? Because they are basis vectors. So if you have, this is the, say, the basis vectors of
Hmm.
X, these are the basis vectors of Y, these are the basis vectors of, so let me write Bx, By, and Bx intersection Y, right? So how can I get Bx? So I will say, let me define B intersection Y as, say, B1, B2, dot, 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 Bk. Okay. So this is, let the basis vectors be this. So that what do you get from this? We get the dimension of X intersection Y is equal to, okay, what will be the dimension of X intersection Y?
Okay.
Okay. Now, Partho, tell me, what will I do with to get the basis vectors of X?
So I'll take a minimal independent vector set which will span X.
So that I want to add on to the intersection set. The intersection set is already doing some spanning, right? Some parts intuitively. The rest of it, say, let us define this as extension set EX and this,
Hmm.
say, EY. So I will write this as, right? So this will be, say, B1,
Uh-huh.
B2, BK, and I can write X1, X2, dot, 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 Xn, say. Okay.
Acha, mane, you are saying the dimension of dx. Acha,
Yes.
just a second. So, but
Now, what is the
e
dimension of BX of of X then?
n plus k?
N plus K. So anything
No,
that
no,
was
no.
left,
Hoinagda.
yeah.
Over here, I didn't understand that this thing means b of x intersection y, and that e
Uh,
of x
hmm.
means the one you how you mane, added them in. I didn't get it. Mane,
I don't like
mane,
what is there. So if you have to do R3, you have a plane. You will just add an extension of any line that is not in the plane, right? You will add any vector which is not in the plane, then you will get R3, isn't it?
mane, I didn't. Art. Oh, yes, means if I have all the
I
lines
am
in a plane,
saying X
can span out to.
intersection Y. X intersection Y. So for that I drew this. If it can be n dimensional also. X can be spanned by intersection of X comma Y. X intersection Y. The basis vectors of
Hmm.
S intersection Y.
Hmm.
Plus the remaining vectors which cannot be spanned. Yes or no?
Ex টা কি
I am
basis
constructing
vector?
Ex. They are basis extension vectors such that Bx becomes a basis vector. For example,
Fine.
if I am given a plane, I can always take any line as my Bx. So this was say Bx intersection Y. I can always take Bx as this.
Okay.
And then
Fine.
any combination will be R3. Yes or no? I just need three vectors and I can take any three vectors which are independent and can solve for alpha 1. So this is what I did. Please, if you have not attended a class, please look at the videos at least. Can't I write this? If they are
Yes.
independent vectors, any vectors, if y is in R3 and xi's are in R3, I will be able to write any y. For all y in R3, I will be able to write it as a linear combination of three vectors. We had intuited this by taking the Cartesian coordinates, the Cartesian
Hmm. Hmm.
vectors.
Hmm. Yes.
So that's what I have done. So if you have only been able to span three-dimensional space into say 10-dimensional space, I would need 7 extra basis vectors to span
Yes.
the rest
Yes.
7. Yeah, that's
Hmm.
what
Hmm. Hmm.
independence. That's what I'm doing. Is it clear?
Okay. Okay.
So similarly, by I will write as bx y inter plus union of ey. Okay. Clear? So let's rewrite as ym. So dimension of by will be m plus k, right? Yes or no? Correct or wrong? Not by but y. Hello, I'm not audible.
Yes,
Is it clear, right?
yes,
So the right hand side, what will it be? The dimension of x plus dimension of y minus dimension of x intersection y. What will this be? N plus k plus m plus k minus k, right? M plus n plus k. Do you agree? Everyone? Partha, okay?
Hmm. Yes. Now m plus n plus k. Yes, sir. Yes.
So now I have to show only the left hand side, right? So there is no problem in the right hand side. But the left hand side, I'll do it. I don't have space here. Let us do it at the end. Okay. So I can also write. So what do I have to show? What is the intuition? Can you tell me? So I have shown the right hand side equal to m plus n plus k equal to dimension of x plus dimension of y minus dimension of x intersection y, right? What is left hand side? Dimension of x plus y, right? Yes or no?
Yes.
So,
yes.
but to get the dimension of x plus y, what do I need?
You need a dimension of x, y, and x intersection y.
What is x plus y? I have already got it in the right hand side, but
M
I have
plus
to
n
show
plus
that
k.
LHS is equal to RHS, right? The right hand side I showed is equal to m plus n plus k. But the left hand side I have not shown is equal to m plus n plus k. Have I shown?
No, no.
Then how will I show?
I'll take
What is
individual vectors in x, the basis of vectors in x, and then add them up. Add each of them.
In X only.
No, in X and Y.
So what
basis
you are
X,
saying, the intuition
basis
is
Y.
what should I do? Is this not similar to something you already know from set theory? That should instantly, like, it's class 5 3/4 level thing in Venn diagrams used to do. You should be able to see and tell me, like, this form is very similar to something you already know from very elementary school. What should be the, so dimension of X plus Y has to be number of basis vectors in X plus Y? Yes or no?
Yes.
Yes.
So tell me, what should be the form of the basis vectors of X plus Y?
Like it should be the dimension of the span of ex plus ex union
Very good.
bx intersection y union ey, and then we
Very
will add
good.
up.
So this is the intuition. I don't know if it is true or yet or no. That we have to prove that, right? You're saying the span of this should be dimension of X plus Y. Yes or no? This is what you said. Not dimension, that X plus Y, right? Yes or no?
Yeah, yes.
So this is nothing but X union Y. I wanted X union Y. I did not want even your, like, the, so it's something like the basis vector. You're right, in some form of the basis vectors of S union Y. You're right. So from X intersection union Y, you should have got this idea. It's good that you got it directly. Good. So now tell me, what is EX union EY intersection BX union BY? This is B1, B2 dot 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 BK, M1, M2 dot 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 M, sorry, X1, X2 dot 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 XN, and Y1, Y2 dot 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 YM. Yes or no? Okay. Okay with everyone? This is the set of the basis vectors. Now, my question is, what do I have to show first? I have to show that, say, let me write S X union Y or X plus Y, something like this. Okay. So now, if I write this, I have to show what? I have to show this spans Sx plus Y. I have to show, at least show that. I cannot just directly say yes or no.
Yes.
Why have everyone fallen silent? Ask me questions if you are not following. I just took the union. I am starting from this point because I know from set theory that X union Y is equal to X plus Y minus X intersection Y.
Yes.
Yes, understood.
Okay, good. So now what will I do? How will I show that this spans X plus Y? If you have understood, tell me.
I will show that the
I
dimension
have
of
to
X plus
show
Y.
Sx plus, yeah, tell.
I will show that the dimension of Sx plus Y equals to M plus N plus K.
No. How to span we had seen last day. Spanning is any element in a set has to belong to, any element in a vector in a subspace must belong to the linear combination of its basis vectors or spanning vectors,
Yes.
right? So if a plane is your span, if a plane is your subspace, then these are your spanning vectors. All the vectors in the plane must be a linear combination of your spanning vectors, right? Just like in Cartesian coordinates, you have 1 0 0, 1 0 0, 0 1 0, and 0 0 1 as the spanning vectors. Yes or no? These are not even spanning vectors, they're even basis vectors. They're minimal. Yes or no?
Yes.
Okay. So now how will I show that? So let z belong to x plus y. Okay. Right. So then I have to show if z belongs to x plus y, then z is spanned by x plus y. Right. I have to show this, then only I can show that the spanning set is. So what can I write? Go ahead.
Like for x means if we write z equals to small x plus small y, then x can be
Yes, go
expressed
ahead.
as
Yes, you are right.
some linear combination of b1 to bk and x1 to
Is it?
xn.
Yes. So we can even make it simpler. How can we make it simpler? Let us not write even three terms here. We can also write this as span of bx union by. Yes or no? If you can make it simpler. Do you agree?
Yes.
Both are same. That's what I meant. Good. Now, if it is bx union by, then yeah, you're right in that way. You can also write this. So you will tell z can be written as a linear combination of 1 to k bi plus j from 1 to n xi plus l from 1 to m yi. Yes or no? Not alpha i's, beta i's, delta i's. Yes or no? Alpha I, beta I, delta I belongs to f, or real numbers in our case, right? Clear? You should be able to write this way.
কিভাবে লিখলি এটাকে?
I don't x is in the x. I have said z is in x plus y. Yes or no?
Yes.
If z is in x plus y and x plus y spanning vectors are these, can't I write z is linear combinations of
Yes.
this? Huh?
Yes, you can write.
That's how you have to do. Please go back and see. We have proved all these last time. Okay, now I can do simple thing. What? I can break this beta bi's into two, say 1 to k. Let me write alpha I1 b1 plus j equal to 1 to n xi beta 1 plus summation of I equal to 1 to m yi delta I plus alpha I2 b1 bi. Sorry, not b1. Why did I do this? Any idea?
Like to create elements of x and y.
Very good. So do you agree these are bi comma xi's belong to bx, the basis of x? Is it clear that I can write this in two alphas, right? Say for a particular case alpha is 5. I can always break it into 3 comma 2. Yes or no? Or 7 comma minus 5. Agreed?
Yes.
So I have written alpha I as alpha I1 plus alpha I2. This is how I have written in this step. Okay. So this is all linear combinations that belong to x, and this is all linear combination that belongs to y. Yes or no? This belongs to y, this belongs to x. So z also belongs to. So you have shown thus s of x plus y spans x plus y. Our choice is correct, but it is not done yet. This is only one side, right? Which is also like this is reversible. That I mean by, say if you have x and you have y, two elements from x plus y, you can also say that the basis vector is the union. So let me just. No, but this is one side is enough, I think. Yeah, this is one side is enough. Don't require. So thus Sx plus y spans x plus y. Is it okay? Because all these steps are reversible. Even if it is both sides, you can reverse the steps. Okay, tell me any questions. So what result did we prove now using this? First answer that question. What did we prove? Now why is it useful that you have to tell me? Why is it useful to prove this result?
Means we proved the basis vector. We found out the basis vectors. Means we
Of x
claimed
plus
the
y.
basis vectors and proved it of x plus y.
We have not yet proved they are basis vectors. Be careful about that. We have shown this span. So this step is showing x plus y spans x plus y. Yes or no? Partho,
Oh,
what is the
acha,
problem? Tell me.
Moinaka,
Yeah,
if we have to prove that it is a basis, then I have to show that each of those means all of those vectors are mutually independent in S of x plus y,
exactly.
I guess.
Exactly. That's what I was asking. So we have currently shown if we can show if s a s x plus y is basis, then I can write dimension of x plus y directly as, see, there are k vectors here, n vectors here, and m vectors here. M plus n plus k, right? Because we've already shown it spans x plus y, yes or no, Partho? Just now we showed.
Yeah, it spans x plus y.
Yeah. So, but now what is left to be shown? So then proved, then done. But what is left to be done? Outreach, tell me what is left to be done. We have shown it spans x plus y, but to be basis vector, what property must it have? Outreach?
Like they have to be linearly independent.
Very good.
B1s and x1s and y1.
So so what is the vector? Say bx union by must be linearly independent. So how will I prove that, Partho? So what is, let me just write down bx union by first, and then you can tell me b1, b2, b3 dot bk, x1, x2 dot xn, y1, y2 dot ym. Tell me. There is also
So
another yeah, before we go continue, I just have, please, there is another thing that I have proved in my other course. Rank a b is equal to rank of b minus rank of null space of b intersection column space of a. Please go back and we'll see what are these spaces, and please go back and see this. Go back and see the previous course. This is not required in your in machine learning, so I'm not doing it, but it is required for your gate if you want to write linear algebra. It may help you prove a lot of theorem which can be asked, which of them following is true and so on. Okay. There's also a this is one important theorem, the one I'm doing now, which will be useful. The second one is, you please go back and see. It's very similar, but it is done extensively before. Brahmojit and all have done that in my previous course. Please go back and see. I'll share the link also in the video. Anyways, now tell me, Parthu.
yes, means that b of x and b
How
of
will I
y.
show? How will I
Uh,
show? It's now you.
yes, so it's a into summation of all those bi's plus some b into summation of all those xi's.
You can't write AI. You have to all new. Linear combination means alpha I all can be multiplied with, right?
Yes, yes, yes. Sorry. I equals to 1 to k plus that beta I equals to 1 to k.
1 to n.
N, yes, plus gamma I is equal to 1 to m.
Yeah. Gamma I, yi. Now, what
I
will it be to be independent? It will be
equals
not
to
equal to 0.
no, man, this will be equals to 0 only for the coefficients are 0.
Exactly. It is not equal to 0, not equal to 0 if alpha I, beta I, at least one of alpha I, beta I, and gamma I is not equal to 0, right? At least one of alpha I, beta I, gamma I is not equal to 0, right? For independence, this is required. I hope that is clear. This is from the definition. Okay, but we will prove by contradiction. Prove by contradiction. So how do we prove by contradiction?
we'll assume that they're not independent.
Let them be, let these vectors be dependent. Therefore, there exists alpha I, beta I, beta I, and delta I or like gamma I, such that summation of alpha I equal to 1 to k bi is equal to j equal to 1 to n beta j xj plus, right? Yes or no? Is it okay? I just wrote this. Clear?
Yes.
Okay, I thought this is simple algebra. Now, how can I argue? So to which subspace does this belong? So you can do one thing. X, this is a homework. X is a X belongs to say X comma Y be subspaces. Then you have to show X intersection of Y is a subspace. Try this. Okay, so what is the left hand side? To what space does the left hand side belong to?
B of x intersection y.
Not B of intersection Y. B is the basis vectors. They
Oh,
are
now x
finite.
intersect. X
They belong
intersection.
to X intersection Y. What does this belong to?
This belongs to x ex.
Again, EX, which is also a subset of X, right?
Yes.
E of X is again an extension set. It's again a finite set. So these two belongs to
Yes.
X and Y respectively, right?
Yes. Universally belongs to x. Yes.
Yes, it belongs to X and Y. See, the left hand side belongs to X intersection Y. The right hand side belongs to, or also you can take one to the other side and do that. So for example, you can also do this. Say, we can add these two is equal to Y, right? This is also possible. Correct? Both ways this is correct. Now my question is, the left hand side belongs to X intersection Y. which is also belongs to X, yes or no? Correct?
Yes.
So the left hand side
Yes.
belongs to X, yes or no?
Oh, acha, and the right hand
Right
side
hand side belongs to
belongs
Y
to y.
minus the X intersection Y.
Yes.
So
Ey.
if you do not take, so but to be equal, what does it have to do? To be equal, other than the zero vector, this must
Hmm.
belong to X intersection Y. Must,
Yes. 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 Yes.
because the left hand side belongs to X intersection Y, and RHS has to belong to X intersection Y. Now you
Nah,
are done.
left hand
Yeah.
side to belongs to x go.
That's what I'm saying. If left belongs to X, Y right belongs to Y, then what? Sorry, I was going to.
Then both of them must belong to x intersection y.
Exactly, that's what I'm saying. Or both alpha i's can be zero, right? Left hand side. Let me just write it clearly. If you have, in case people when they read, they will not understand. Left hand side belongs to X. Yes or no? Let not subset belongs to X. Yes.
Yes.
Right hand side belongs to Y. Right. Now, only possible if LHS, comma RHS belongs to X intersection Y. Yes or no? Right? Or
Yes.
alpha I equal to beta I equal to gamma I equal to 0. These are the only two cases, right? If this is the truth, then we are already done. They're independent. But let us take this done. But if this is the case, the first case, what will I do? What can I write? How can I disprove the statement?
Zero কেন বললে গো মইনাক দা?
This equation, if I put all the alpha i's, beta i's, and gamma is equal to 0, will the equation not hold?
0 equals to 0. Yes, it will hold.
So that's why. So the first case when LHS and RHS are both different, they must also belong to the intersection, right? Those vectors must belong to the intersection. Yes or no?
Yes.
Then how can I help?
Okay, then I mean x and y will become equals to, means they will become same.
Let us see.
So
So do you agree that I can write this? So this belongs to, now I know X intersection Y. So what can I write this as? Some delta I Pi's, yes or no? Pi span X intersection Y, yes or no? The right
yes.
hand. This is a vector in X
Yes,
intersection
yes.
Y. So I can write that as some linear combination of the basis vectors in X intersection Y, yes or no?
Yes,
So
absolutely.
now see. So this is nothing but I m alpha I yi plus delta dash, say some delta tilde of pi, summation of I equal to 1 to k equal to 0. Now see,
মাইনাস হবে তো?
I put delta tilde, see, on the head.
না মানে মানে those are minuses of delta is.
Yes,
আচ্ছা।
that's what I'm saying. So what does this mean? So what is y1, y2 dot 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 yk or ym b1 dot 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 bk? They are by. So they can never
They
they
can
can never sum to
never be
0.
dependent, yes. Cause they're
So
already a basis.
yes, so all gamma I must be equal to 0 for all I. Similarly, all alpha I, beta I is equal to 0. Therefore, we have proved that this is true. Clear? We went very slow. I hope it is clear to everyone.
Yes.
Okay. So we have proved that the sum is equal to the sum is equal to the sum of individual dimensions minus the intersection. So let's take an example. So let's say, what would this be? So you have a plane and you have a line. Just mix at 0, 0. The dimension of x plus y will be equal to, tell me what is the dimension? This is x, this is y. Dimension of x plus dimension of y minus dimension of x intersection y. What is dimension of x?
2.
Dimension of x is 2,
What is dimension of y?
1,
What is dimension of x intersection y?
1.
1. A point has one dimension.
Now, oh, it is cutting the plane. Acha, 0.
Otherwise, so if the line is not in the plane, so it's 3. So you see the x plus y, this is called a direct sum. When the intersection is just 0, you get a direct sum. Similarly, you have two planes in R3. So recall where do two planes intersect?
Along a line.
Along a line. So dimension of x plus y, see again, x is 2 plus 2 minus dimension of line is equal to 2 plus 2 minus 1 is equal to 3, as you expect. So it can only map up to R3. The idea.
এখানে মানে for intersection of two planes, মানে they can never intersect at a single point, I guess. তো ওই জন্য ওটা one ই হবে।
Parallel planes.
ও হ্যাঁ, তাই তো if I have parallel planes, then ওটাকে 0 নিয়ে নেবো কি?
Parallel planes you can never add two parallel planes. We have seen last class. Otrij, why can't we sum two parallel planes? Why will this not hold? Romojit, why will it not hold? Why can't we add two subspaces which are parallel? Yeah, go ahead.
Because they won't include the 0 vector.
Very good. Why are you not telling? Good. So if they're parallel, one of them don't have 0, so it's not a subspace. We have shown that last class, right? 0 must be contained for a space to be a subspace.
আচ্ছা, সাবস্পেসের কন্ডিশন কি ছিল? That 0
linear
must be
combination of any elements in the subspace must belong to the subspace. That's the only condition. Please go back and see. Linear combination of any
Sir.
elements in the subspace must belong to the subspace. So if you see you have a line like this, you can never have this as a subspace, because two linear combinations like this will always be out of the subspace. Okay, so we'll now do what is known as 4 fundamental subspaces, which is the central theme of machine learning and how we do matrix multiplications and so on. So why is it important to learn these, and what are these pictures? It will become gradually understandable to you. Say, Utrij, we discussed last time. Do you remember what is AX? What will be AX if A is a matrix? A is a matrix saying Im cross n. Ax would be, where should it belong to?
Means it should be a column vector again of
It
size
will be a column
x.
vector of Rm, right?
Yes.
So we had seen last time A1 to An. If Ai's are Rm vectors, what has to be the dimension of x? How many numbers should be in x? And how did we find it out? There should be n numbers, right? For a conformable multiplication. And why was the n numbers? Why was it n numbers? If you recall, we had seen it from the Vedic mathematics last time. That x1, this was equivalent to writing x1 a1, x2 a2, dot dot dot, xn an, right? Recall? This is how we wrote.
Yes.
Okay. So what does this mean? What does a vector matrix multiplication do? When I multiply x to a, where does it project to? Where does it project? What do I get?
To the span of the matrix.
Span of the columns of the matrix. See, this
Span
is a
of the
linear
column.
combination of what? Column vectors. Yes or no? Agreed? A vector matrix multiplication is a linear combination of the column vectors of the matrix. Okay. So this is called a column space or a range space. What is a range space of a matrix? It is defined by range space of A or column space of A is the set of AI, Xi, AI in Rm, and Xi belongs to R. Or you can just write Ax for all x in R to the power. What is the dimension of x?
N.
Good. Right? So this is a set of, you take all the vectors of Rn, multiply with the A, and do you agree you will get a vector space like this? Uthrij, like last day you were asking me, what does a plane look in higher dimension? It will look something like this, right? It will project onto this space. Clear? So this is
না আচ্ছা মানে
us.
ওই আরে দিয়ে কি লিখলে গো আমি ওটা ঠিক ফলো করলাম না আরে আরে সামথিং ইউ ডোন্ট না আফটার
I wrote
এক্স
the
বিলং
column space.
হুম
Which one? I wrote the column space. I wrote it here now. The linear combination of the columns is in the column space. Any
Yes.
matrix, any vector matrix multiplication is going to give you a element in the column
Column
space. We
space.
just saw
Yes.
that. We saw this. So I
হুম
wrote the column space as a set. That's what a space is. It's a
AI
set.
xi belongs to R yes yes
Xi, this is just way of writing linear combinations of the columns.
হুম
These are the weight vectors, and these are your column vectors. Yes or
আচ্ছা
no?
and so what is that RA equals to call a
RA is also known as the range space. Range, it's called the range because of a range of a function. So you can just think it is of n functions. M functions of M linear functions. We saw this last time. If you haven't seen the big video, please go back and see. This can be a function, x1 plus x2. This is where we started from,
yes
right? Yeah. So it can be n function. That's why the space of the range is known as the range space.
range acha mane given n functions, their combined range is the range space, right? If I take the linear
Yes.
combination.
In linear
Fine.
functions, in linear affine transforms, which can also be written as a vector matrix multiplication ax. X is any vector in Rn. So first of all, let me clear A has to be, let me write A as A1, A2, An is M cross N matrix, that is AIs are Rm matrix. Okay. So there are M equations and N unknowns in our, according to our previous notation. Yes or no, Utrij? So if we started from N equations and N unknowns, so anything along
Yes.
this, along the rows are your equations and along the columns are your variables, right? These are your variables v1, v2, vn, and this is your equation 1, equation 2, em. Okay. So now is it clear? So you take any x and multiply it with a, you get the column space. But do you also agree if a's are not independent? Then say if, so we have understood what is a column space. We'll see the properties later. Is it under any questions regarding column space? If there is no questions, if I ask you what is a column space, what will you tell me? You don't need to remember any mathematical notation that will flow through your hand once you know the concept. Once you know this geometry.
The span of
Partho,
the
if I
column
ask you
vectors.
what, yeah, Promojit, tell me.
The span of the column vectors.
Span of the column vectors. Very good. Another way of looking at it. Span of the. Do you agree with Promojit? Everyone else? He's just said everything in a single. He used the notation that we have used or the definitions till now and gave the definition in terms of span of column vectors. See, now you have related span, your columns, your matrices, and your linear combinations. Everything is related now. Now tell. Now if A's are not independent, if AIs are not independent, then
Then it is
then first, so here I'll take the
then it is the
the
span.
no span is okay. Here I will take the, I'll take an opportunity to give you a homework, show that range space is a subspace. I will show for the null space and then you can show, we will show for the range space. So for showing it in the null subspace, what you will have to show? That any linear combination in the subspace will belong to that subspace, right? So if x comma y belongs
Yes.
to Ra, alpha x plus beta y must belong to range of A. This is what you have to show. So if I say that
Your video froze. Hello?
am I audible?
Your
Yes, now.
video froze.
It's okay, it will come back. Is it okay now?
Yes, it's okay now.
So my question is, if AIs are not independent, Brahmajit, what can happen? If AIs are not independent, what can happen?
Then you do not get access to the entire span. You kind of get
That is
limited.
true. You cannot go, but if they're not independent, then what can happen? So there can belong x such that ax equal to 0, such that x is not equal to 0, right?
Yes.
Because if they are not independent, there will be, what will there be? Xi ai's I equal to 1 to n can be 0, right? If ai's are dependent,
Yes, yes, definitely.
yes, so this product can become 0 if they are not independent. And the space, so we say the null space of a matrix n of A, this is called the null space, is defined as all those x such that Ax is equal to 0. X belongs to Rn. So this is your null space, right? This belongs to Rn. This belongs to Rm. Yes or no? Column space
আচ্ছা এক
belongs to R.
সেকেন্ড মৈনাক দা মানে
Yeah, I will show it's a subspace, but for the time being, think it is a subspace.
means all x such that ax equal to 0. So null spaces are collections of মানে x's for which the ai's are dependent.
For which the linear combination of columns is equal to 0. Or the matrix vanishes if you multiply with the vector.
Okay. So if my can it ever be that my column space becomes equal to my null space?
How can column space be equal to null space? Column space and null space, see, column space, that is only case of zero vector.
Yes,
Only
yes. Only the
because if you
zero
multiply,
vector is there.
of course, because if your null space is what? So now you're saying that how can they even be same? See, they're dimensionally different. How can it be? In square matrices only it can be sometimes the case. They are independent pictures. That's why I drew them differently. So A is in Rm, right? Yes or no?
Yes.
And null space of Ax, that is column space, is in Rm. The null space is in Rn. How can they be in the same space?
Rn. Yes, yes.
Only in square matrices can that ever happen. What I said, zero vector. But they are not related. They are not in. I'll show you some things like they're like why I drew this picture, but then it will become clear. So just keep this. Yeah.
One thing to ask, what is the range, that range space, that is a subspace of which subspace? Means it is the subspace of the what vector space?
I wrote na Rm. Let us just see this na. We'll see. Bear with me. So this, look at this picture. This equation we wrote. Remember from the first thing we did in linear algebra, we wrote we could multiply each of the scalars in the vector along with each of the columns, right?
Yes, agreed.
So what are AIs? Which space they are in? Rm?
Yes.
So the sum of all Rms would be in Rm only. But that can be, you are right, that is the total vector space. But the subspace which is it is that can be different. Okay.
Yes, understood.
That is the total space. Total, if you are taking a 3D space, that will always be in 3D, right? It can be a 3D, full 3D, 2D, or 1D, or 0D also, if you have a zero matrix, right? Clear?
Yes, understood. And can you explain that zero, that square matrix part that you told just before?
Just don't think about it. Let us complete everything, and then we can, like, square matrix and all, we can see. See, these are in square matrices. These spaces are same dimension. That's what I said, right?
Acha, understood.
So if they're in the same dimension, see, Ax is equal to 0. 0. So your Ax is 0 is always in the column space. Yes or no?
Yes.
So if A, that X will never be in column space, right? If it is in the column space, it cannot be in the null space. Column space are all those vectors. It is all those vectors that now there's a question. It can also be in the column space because it's all those vectors, right? AX, combinations of AX, right? What is the column space? Just to be clear, it's the vectors AX, right? The multiplication vector matrix multiplication AX, yes or no?
Oh, yes. Means you are telling that if the dimension of X is n and the multiplication also projects the vector into column space
Correct.
of dimension n, then A is a square matrix.
Correct. So AX, when will these two conditions hold? See, AX is set to be 0. So this has to be 0, right? And X is set to be in the column space. So X is also set to be in the column space. If X is also in the column space, X is also in the null space, it means it's a 0 vector, yes or no?
Yes.
Column space are AX multiplication. So AX, if you multiply and get some, or wait, I just think, let me think. Can the null space vector be written in the, no, then you will have to think about it. It's not directly like that. I'll come back to it. Let me just complete the null space definition first, then I'll come back to this question. Okay, null space is the set of all those vectors such that Ax equal to 0. And now I want to show that the null space is a subspace. How will I show that it is a subspace? Just to complete my way of thought, I'll just complete this. How can I show?
First, I'll just see that any two vectors x and y from the
Okay, V1 and
null
V2.
space.
Okay.
V1 and V2 belongs to null space. I have to show that for some AV1 plus BB2 plus beta
How will I show?
V2 also belongs to null space A. Fine.
Right? This is equal to 0, right?
Yes.
Yes or no? So this is
Yes.
true. So this is a subspace. So I have shown, which is a subset of R to the power n, right? This is a subspace. I should not use belongs to, I should use a subspace, right? I'll show you why. But now my Parthos question is, let me complete the other two definition also, and then we'll go to that question. So the other is the row space. What will be the row space?
The linear combination of all the rows.
Good. Linear span of the rows.
Span of
right?
rows, yes.
Which is also equal to writing A transpose X. Yes or no? Or Y transpose A. Correct? Both are same. Such that X belongs to R to the power of X comma Y belongs to R to the power ball.
So row space equals to column space for a symmetric matrix.
Yes, that is very clear, na? A equal to A transpose, of course. But is the definition of row space clear? If you once you know null space and column space, both the other two are definitely clear, right? So this will be, in which space will this, what subspace will it be? R to the power n, yes or no? If you cannot visualize, let's take.
This is basically the column space of A transpose.
Correct, column space of A transpose. Very good. O3 is clear. This will be R to the power n, because M was with A, so A transpose is n cross M matrix. So it's the column space of A transpose, yes or no? Others clear?
Yes. Can you
Now,
explain that Y transpose A part? Means
আরে সেম থিং রে, এটা ট্রান্সপোজ নিয়ে নিলে হয়ে যাবে। Y transpose
আচ্ছা আচ্ছা আন্ডারস্টুড আন্ডারস্টুড।
Look, I'll also show this. This is useful. Good that you asked. Say you have a matrix. Okay, now let me write it as rows instead of columns. Say let me write it as row 1, row 2. How many rows will I have? Rm, right? Ri belong to R to the power n, right? If it is a m cross n matrix, yes or no? Ri
Yes.
belongs to, I think it has not yet come now. No, it has come now. So on the right hand side, if I were taking linear combination, I was converting into rows, right? I was converting linear combination of columns. If I do a left multiplication, say b1, b2 dot 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 bm, it will be b1 r1, b2 r2 dot 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 bn rm, right? We column or row একই জিনিস, they're stack of numbers. Generally, to have uniformity, we always think vectors as column vectors so that there is no lack of uniformity. Okay, but some books will just say we have row vectors, like MATLAB loves row vectors, something like that. Okay,
আন্ডারস্টুড।
একটা ডান দিকে মাল্টিপ্লাই করলে কলম গুলোর কম্বিনেশন হচ্ছে, বাঁ দিকে মাল্টিপ্লাই করলে রো গুলোর কম্বিনেশন হচ্ছে, বুঝেছিস?
হ্যাঁ।
So what will be null space of row space of, let me just write it down, or null space of A transpose, this will be Y
Y so that A transpose Y equals to 0.
or Y transpose A equal to 0, Y belongs to R to the power of M, right? Again, you can show that they are column vector spaces, and we will show that they are orthogonal. We will show this. So this is null space of A transpose. This is also subspace of R to the power n, and this is subspace of null space of row space of A, row space of A, which is subspace of R to the power n, right? How do you remember? Rows are n numbers, so the rows are consisting of n numbers. So therefore, it must be a subspace of R to the power n. Columns are m numbers, must be a subspace of R to the power m. And since you're taking linear combination of rows to get 0, that must be with the linear combination of columns to get 0. So the null space should be with the row space, because it has to have the same number of elements as the number of columns, right? The null space must have same number of elements as the number of columns, because AX has to be equal to 0. So this has to be n cross 1 dimensional, yes or no? Right?
Dada, one thing to ask, why did you write null space of A transpose for column space?
What's column space now? Column space সাথে লিখেছি, I wrote with its column space.
Means
Null space
of the CA thing in the diagram.
CA thing I wrote AX belongs to RM, right?
No, the connected part.
Okay, I will show that. So they are two different subspaces connected by 0.
Oh, acha. All right.
Like null space of A transpose and column space of A are connected only by 0, right?
Okay.
Will show, because if you multiply A into 0, it is 0, right?
Yes.
Correct. And what is in the null? How do you define null space? These are all the vectors such that Y transpose A equal to 0. Correct. So you can multiply 0 to A and you will still get 0. Yes or no?
Yes.
Yes, sir. So both of them are 0. 0 connects both of them. We'll see it like a better picture, but the definitions are clear, right? So linear combination of rows is the row space, linear combination of columns are the column space. So if you multiply right hand side column matrix vector, you get a element belonging to the column space. Left hand side, you get an element in the row space. Null space is the linear combination of the columns that gives 0, and null space of A transpose is the linear combination of the, complete the sentence, null space of the rows or the row space.
A linear combination of rows that gives 0.
Okay, how many dimension the linear combination of the rows that gives 0? So how many dimension will your row space be or your null space be? Like what
Oh,
subspace?
in.
Because you need n numbers to multiply with each of these columns, right?
Yes.
To get Ax equal to 0. Now coming back to that difficult question of what did you ask, Partho? Can you go back? Can you ask me once again?
What did I ask? I don't remember. What which are referring?
Huh?
Means what did I ask that?
The column space and null space. What elements do they have in common? Something like that you asked.
Yes.
Null space of A and column space of A. See, column
Yeah.
space of A belongs to R to the power of, help me.
R to the power of m.
Good. And null space belongs to R to the power of,
Power of n.
yes, x1, x2, dot, xn. Good. See, steps. First is they are null space of A, intersection column space of A is not defined if m not equal to n, right? So they can never have common elements, right? Not even the zero vector. They are in different spaces altogether. Agreed?
Yes.
Dimensionality means match. So they can never have common elements. It's not defined. Now my second question is m equal to n jodi hoy, then my null space is defined as what? Let me write down the definition once again. X such that Ax is equal to 0, right? And column space of A is yes or no? These are the two definitions of column space and null space. Is it
Yes.
clear, Partho? One, it is first taking it is all the vectors in Rn and just seeing where it is equal to 0, right? And you make a subspace out of that. And then second one is all the vectors and then multiplying it with A and seeing the plane it forms, right? So let me just multiply. So say Ax, right? So say A, go ahead. Say A belongs to the column space of A. Yeah, ball.
The thing is that what are we doing by the column space here, right? When we are writing column space, what we mean is Ax equals to B. Also, all the B's are part of the column space.
Exactly, I'll show that only. So say
For the
X is
null-
in the column space. Okay. So
For
X
the
is in the
null
column
space,
Hmm.
for the null space, Ax equals to 0. All the X's are a part of the null space.
Correct. X are all the part of the null space where Ax is equal to 0.
And since we are considering a square matrix here, it can be invertible. An inverse might exist.
Correct.
So I feel we have a very fortunate common element which will be a zero vector. Nothing else can be common.
Let me just check if it is 0 or 0 vector or not. Say this is column space, this is row space, this is null space, this is null space of A transpose. Okay. So say X is in the column space of A. So can I write X as AY such that Y belongs to Rn? Yes or no? There should be a Y such that there should be a Y in Rn such that is my video still frozen?
There should be an y in Rn such that ay equals to x.
Yes, because it's the set of all the numbers which are linear combination of the columns, right? So if I say is to
Yes.
not confuse you, let me write v1 v2. Say v1 belongs to column space of A, right? So v1 can be written as A v2. Yes or no? Agreed?
Yes, agreed.
Good. So now you tell me. So you said that v2 or can v1 also be? You're saying can v1 also be in null space, right? Yes or no? v1 is in column space intersection null space of A, right? This is your question. अरे तुई तो क्वेश्चन जिज्ञेस करली तुई बोलছিস না I knew.
Yes, yes.
So v1 you are saying
Yes.
is in the null space, right? Okay.
Yes, can also.
Now let me just do something like this. So A, I multiply both sides, right? So I get A into v2, correct?
Yes, correct.
A squared v2 is equal to 0.
হ্যাঁ ওটাকে 0 হতে হবে। হ্যাঁ, yes.
Now if A is rank n, you can show that A square is also rank n. We'll show that. So you can show that. So I showed that na rank of AB is equal to rank of B minus dimension of rank of, what was the formula that I had given to you? Let me just check once. Let me just check the formula. I don't remember it exactly. I just give me one moment. We'll use that formula.
CA.
Yes, null space of A intersection of column space of. Okay, I think I wrote that a bit incorrectly. I'll just correct it. Just give me 1 second. Give me one moment. Null space of A, yeah. Null space of A into column space of B. Easy way to remember. I also forgot because I did not derive it. Where is it? Where is it? I think I wrote somewhere. Where did I write? This is last days. Where is today? Yeah, today's session. Null space of A into column space of B, right? This is what I column space of B. Good. So now tell me the null space of A into column space of B here. What is it? So I'm just being, so they are both, this is exactly this set that you want to find, right?
Yes.
Rank of, so they say this is rank of A. Oh, it's we are right. So we cannot, it cannot be invertible. So V1, no, how did you say it's invertible? So it cannot, need not be invertible, right? A need not be invertible if it is n cross n. It can still be non-invertible matrix. 1 1 2 2 is not invertible, right?
Yes, because if it is singular, it will not be invertible.
Correct. So you will get a v2 comma a is equal to 0, and you have shown you will have to, I think, a square v2 is equal to 0. So what, if it is invertible, then you will get v2 equal to 0. Otherwise, you are not going to get, right?
Yes, then I can take two inverses and then say that v2 equals to 0 if it is invertible.
But if it is not invertible, what can you do? If it is not invertible,
Can
then
we
you have a
apply?
problem.
Yes. Can we do a pseudo inverse or such stuff here?
Oh, it will not be useful. Let's see. Romojit, you were talking about inverses, right? When you said that.
Yes, sir. Yes, sir.
So but
If the
inverses
inverse
cannot be
does
done.
exist.
If the inverse exists, it is okay. If A is full rank, then null space anyways is equal to 0. We'll see. 5. There's no null space. If it is full rank, then to now all are independent vectors, right? Then to it's already 0. It is trivial. We'll see what is rank. Don't rank means A1, A2 dot 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 AN. All are independent. Then rank is equal to n. We'll see what this means. Just give me one moment. So if V1 belongs to column space of A, intersection null space of A V1 is equal to 0. A V1 equal to 0. Yeah, then it is, that's what I was writing. Good. So your A V2 will be in the null space of A. That is V1. We are going back to that can happen. So you may have, so what I mean by this is you may have non-zero elements, right? So you can take V2 to be in a particular space, in any space, any rule V2 you can take and multiply that V2 with A, and you get V1, right? Yes or no? But by definition, V2 cannot be in the column space. If it is in the column space, what will happen? You could write V2 as again A V3 and so on, right? There are two cases here. So this is generally therefore not trivial. Like you can have elements that are not common. I said V1, just follow with me from here. So V1 is in the column space of A, intersection null space of A, right? Right? So I can, from the definition, I can write V1 as A V2, correct? Linear combination, some linear combinations of the columns of A. Similarly, I can write A V1 as equal to 0 because V1 is also in the null space. Do you agree?
Yes.
Good. So now tell me, so if this V2, this now it becomes a recursive problem. Now this V2, if this is in the column space or not. If it is in the column space, I can write it as What can I write it as?
AV1.
Not V1, V3, some other V.
AV3. Yes. Some other V.
AV3. And this will go on forever. And V3 is in the column space or not. So if this is in the column space, this is possible. You can have elements such that because why am I saying that? Because these two are not they are not perpendicular to one another, right? So they can have common elements here. They can be very, very non trivially linked to one another, right? So you can have elements, say V1, right, in the column space itself and the null space. You cannot have elements in the null space like V3. It cannot never be in the null space. Then if multiply it gets 0. But you can also have elements in the column space. Why am I saying this? Because say your V1 is in the null space. V1. Okay. This is what I wrote. So I could have any element, right? Such that which can be in any of these vectors, row space or column space and so on. But when I multiply, say this is V in some row space V2. When I multiply A, I will get V1. Yes or no? I'll get in column space, yes or no? When I multiply V2, which is not in the column space, if it is already in the column space, then there is no answer, only 0 can be there. So ideally speaking, your column space and your null space can be linked to with one another, but they need not have common elements. So that's why we were not able to find a closed form of the common elements here. Any questions? I had an element in the row space. I multiplied A. When I multiply a vector to a matrix, I get an element in the column space. Yes or no? Are who asked the question? You are not only responding.
Yes.
So if I am multiplying that, say this vector I multiplied with A and I got this V1. But I'm also saying A V1 is equal to 0, which means that can also happen, right? So that it comes to this matrix. This can come to this both of these spaces, both elements can have common elements. But the intersection need not be a subspace. Those are again other things to worry about. There will be a subspace because there are two. Why will these two be a subspace? Intersection of these two. They'll have common elements, I said. So why will it be a subspace? So go back and see this rank thing, you will understand why can it be. But just tell me, why can it be a subspace?
Could you please repeat which area are you asking?
There is not a geometric way to say that. I'm saying there are elements between these two which can be common. I'm just saying that.
Between null space and column space. So
that's what we saw, that a square V is equal to 0, which means A of V2 is equal to 0. So V2 was in some row space or some other space. When I multiplied it with A, I got an element in the column space, which is also in the row space, right?
yeah, because it will always be two vectors from this. Their linear combination is also like, because the intersection of two subspaces will always be a subspace, right?
Yes, intersection of subspace is a subspace.
Is always a subspace.
Good. Okay. So let us take an example and like solve this doubt. So let 1, 1 and 2, 2. Right? If I have this matrix, 2 by 2 matrix, give me an element in the null space. O3, give me an element in null space.
-2, 1.
-2, 1.
1.
Right? If I multiply these, what will I get? -2 into 1, 1 plus 2 into 0. Right? But in this case, what we are seeing is, but we also want -2, 1 to be in the column space. Right? I'm not seeing if it is possible in this case. Should be possible in some other case, but it is not possible here. Okay, we'll get back to this with an example, but they can have common elements, which is what I am trying to say, as we see in this. But for the same matrix, I'm still a bit confused. How can they have common elements?
Like Dada, here determinant of A was 0. So
Correct. Determinant of A is 0, so they're not invertible. I'm saying. So go ahead. What is your question?
no, means then it is difficult to find some element in column space. That is what I was saying.
So in column space, you're right. So it is just 1, 1. This is your column space, right? 1, 1's combination, right? So yes or no? Linear
Yes,
combination
yes,
of
yes. Yes. Because if I
But
have x to 1, 1 plus y in 2, 2, so is x plus 2y into 1, 1. Yes.
right, a into x plus x and y. These two you are going to have. This is your column space. But what is your null
Yeah.
space? What is your null space is? Your call space.
Uh,
So your null space will be
null
all
space to 1 I have got -2, 1.
any alpha into that. One only is enough. We'll see why. -2, 1. So this is your null space. Right? Null space of A, column space of A. But here, so we see that there is no common element except 0, 0.
Yes.
But there can be cases where there can be common elements, I believe.
Yes, if the null space would have intersected and would have gone the other way around, so there would have been an intersection point between
The
the
null
column space and
space intersected. So they have to, the null space should have been 1, 1, right?
yes.
So let's take an example. Done. For this matrix, they can have common elements. We just wasted a lot of time just to see an obvious thing. So getting counter examples is a bit tricky because it's not a direct thing, right? So what is the column space of 3 here? May or may not have. Please tell me. If you have, I just want to see everybody's understanding. What is the column space of this matrix? One comma one and minus one comma minus one. What is the, along which direction is it there?
Y equals to epsilon.
Yes or no? They just multiply x comma y. What will you get? X minus y into 1 comma 1. Yes or no?
Yes.
What is that? What is the doubt? The number of independent columns of A will be the column space. We discussed that, right? This is why I tell. What is so confusing? Just forget what we are doing for now, and tell me what is the definition of a column space?
Like the linear combination of the columns.
Linear combination of the columns. So here, what are the linear combination of the columns? Alpha 1 1 and beta.
Minus one minus one.
So what is it? Alpha minus beta 1 comma 1. Yes or no?
Yes.
So this can be written as some delta 1 comma 1. So 1 comma 1 is your column space. Yes or no?
Yes.
আরে এমন প্রশ্ন জিজ্ঞেস করলো, সলিউশন বার করতে করতে সবাই কনফিউজ হয়ে গেল। Good, you are, when you see this later, it will be easier for you. Again, A211. What is it? Patrij? What is A211?
And 0 0.
So 1 1 is also in the column space, yes or no? Is also in the null space?
Yes.
হয়েছে পার্থ? Example?
Yes.
So that's why we draw it separately. They can have common elements provided they are in the same space, right?
Yes.
So, and we should not intermix them until necessary. Then
Hmm.
otherwise you will have confusions like this.
Yes.
Okay, so but how do you find it? So that was what I wanted to do like half an hour back. Let's try, but we have already done half of it. How do we find it? We're going very slow. One more class will be required, 2 more classes minimum. How do we find this? How to find the subspaces? Any idea?
Yeah, so we can take the means V2 as an arbitrary means by which we will multiply this A, say
All
X.
these things will not work. All these things will not work. You have to find an algorithm that you can code in your computer. So first of all, tell me, what is the definition of? So first, let us do 2 things: column space and null space. Okay. If I have to find column space and null space, how will I do it? So let us do it in one way, and I'll show you another way which you can write a code for. So what should be the step to find column space? Otrij, can you tell me? What is column space?
Like the linear
Please
combination of 1 2 5 1 into alpha.
Linear combination of columns. So I will need to find basis vectors, right? Yes or no? The
Yes.
columns can be dependent. As in this case, I can already see a few columns that are dependent. Right? We can see them to be dependent.
Like
They
which
can.
two?
We'll see. We'll see how. But how do you think we can find out if they're dependent or not?
Then
Yeah,
we
Let
can
us
go use the definition of linear dependence and independence.
correct. So see, say X belongs to the null space of X belongs to null space of A. Okay. If then what can I write?
Ax
What can
equal
I
to
write?
0.
Yes or no? Good. So can I also write E AX equal to 0? E is some matrix.
কি ই মান ও আচ্ছা হ্যাঁ
Some matrix. Correct?
Yes.
Is it so do you agree that X belongs to null space of A would imply X also belongs to null space of EA? Yes or no? Why am I writing? It will be clear in just a while.
Yes.
Good. So now E is called an elimination matrix. I think we did elimination last time, Gauss-Jordan elimination. Recall?
Yes.
In which, what did we do?
But we did not multiply there. We performed row operations and
What is row
simplified it.
operations? We'll see now. What is row operations? Let us see. Say, what? Forget about row multiplication now. You agree that row elimination matrix, row operations we did? We
Yes.
did row. Okay. So here, what row operations will I do to get things 0? Tell me. What are the row operations? R2. What did we do? We took first as we called this a pivot, right?
Yes.
মৈনাক এটা কি এশেলন ফর্ম
This is called an echelon form, but everything is an echelon form. We did it last time. This is called a row reduced echelon form.
কি কি কি
Row reduced echelon form.
আচ্ছা রো রিডিউ হ্যাঁ
Or
এলিমিনেশন তো কলাম ওয়াইজ
Gauss
হতো
using Gauss-Jordan elimination. There's nothing in name.
আচ্ছা আমরা যেটা বলতাম গসিয়ান এলিমিনেশন অ্যালগরিদম ওটাই কি
I have taught Gaussian elimination algorithm last time. That's the same thing. Please go back and see. I can't explain that same thing again and again, which is already done. Because that is already done clearly once. So
2R1.
Gaussian elimination means making everything below it 0. And that is what, if I don't know what you call Gaussian elimination, I call that Gaussian elimination. And Gauss-Jordan is making everything other than the diagonal 0. Okay, so alpha R2 minus 2R1. Yes or no?
Yes.
Similarly, you can do R3 as R3 minus 5R1 and R4 is equal to R4 minus R1. Correct? Tell me now, what are the values you will get? 1, 1, 1, 1. Let me just write down. Second row will be 0, 0, 2, 2. Yes or no?
Yes.
Third row will be 0, 0, 2, 2 again. And what will be the fourth row? 0, 3, 5, 7. Correct? Is it clear?
Yes.
Not so clear?
Yes, it's clear.
Okay. So if it is clear, now you ask me why is it multiplication and this same? That's what you asked me, right? Utrecht?
Yes.
Now tell me, can I write this operation in terms of an elimination matrix? So all of the things that you had done can be written in terms of an elimination matrix such that, so this is say A1 such that you can write EA is equal to A1. How to write? What will be E? Tell me. Use the concept of linear combination of, so you're multiplying it to the left. So you will have E1, E2, E3, and E4. And then you will multiply with A. Right? So here, what are you multiplying? How are you reducing the rows? So do you agree that the first row will remain the same?
Oh, I guess, and then the second row will be 0, minus 2, 0, 0, like this.
0 minus 2, 0, 0. Let's see. Let me just write down the matrix once again. This is how you generate the EA matrices. I'm trying to show you that. Okay. So tell me, O3, I want to convert this to 1, 1, 1, 1, 0, 0, 0, 0, 0, 3, 2, 2, 5, 2, 2, 7. How will I do? What matrix will this be? Could you at least interact?
Yes, yes, I'm thinking.
Yeah, so which row am I using to do the row elimination? Which rows combination am I taking? I want to subtract 2 times this row from the second row, yes or no?
Yes.
Yes, so I need to multiply that by minus 2, the first row, and the second row by 1 somehow.
What does this mean? Say R1, R2, R3, R4. You have 4 rows, okay? What does this mean? E1, E2, E3, E4. I just now told you O3. What is in the beginning of the class? What does this mean?
To E1 R1, E2 R2, E3 R3 summation.
Moinant,
So
it's
what will
basically a row space go.
again row space, null space? What row space here?
E1 R1, E1 R2 করছো, এটা তো linear
This is just
combination.
one element in the row space.
Yes,
Not
it's
row
an element
space.
in the row. Element.
So tell me now how to get, so your second row. The first row, why did I put 1, 0, 0, 0? Understood? This row will be
Yes.
converted to 1 times row 1 plus 0 times row 2 plus 0 times row 3 plus 0 times row 4. Yes or no? Will be your new row. New R1. Yes or no?
Yes, yes.
The second, tell me the second one.
Like
What did I
1
do?
minus 2,
Minus
1
2.
minus 2. Oh, achha,
One
sorry,
where?
minus 2, 1.
Yes, minus 2 times
0,
the
0.
first row. Yes, minus 2 times row 1 plus row 2. Third one will be
Okay,
minus
minus 5,
5.
0, 1, 0.
And fourth one will be minus 1, 0, 0, 1. Right?
Hmm.
This is how you make elimination matrices. And last day we had seen, we had converted this to an upper triangular matrices by, so this will solve our this question. This is called A equal to LU decomposition. E is equal to, so do you agree, E1, E2 dot 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 En A is equal to some upper triangular matrix, right?
Yes.
We will do multiple row elimination like we did last time. Just take the inverse of this. Inverse exists for elimination matrices. Exists because it is some identity matrix plus some matrix. Inverse will exist. So you will have En inverse, En minus 1 inverse dot 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 E1 inverse A. What are E matrices? I'll give you a simple example. Let's take this example. They're all lower triangular matrices, right? Lower triangular, yes or no?
Yes.
Let us take
Yep.
one lower triangular example. 1, 1, 1, 0, 0. This is one elimination matrix. Correct? Some E. So now see E inverse, what will it be? Just do the math. It will turn out to be A0, 0, 2, 1, 1, 0, 0. Just the multiplication. Always it is not true, but in this case it will be true. Let's see. Let's multiply A inverse E. What will you get? So first row remains as it is, yes or no? Second row also remains as it is. Arey Baba.
Yes.
Now tell. So first row will be this into the linear combination of these rows, right? So it's just the first row. Agreed? This is why you should have that picture, summation of the columns, summation of the rows, right? What will be the second row? What will be the second row, Partho? After multiplication?
0, 1, 0, 1, 0.
Why are you multiplying like school children? This is 0, 1, 0. So you'll just take the middle row.
Hmm.
Then the third one,
0, 0, 1.
just বলে দিলেই হলো. Why 0, 0, 1? 2 into 1, 0, 0
2 into minus 2 plus 1 into that 1 into 1.
plus 0 plus 1 into minus 2, 0, 1 is equal to 0, 0, 1. Understood? Is it clear?
Yes.
So the inverse of lower triangular matrices are also lower triangular. Inverse of lower triangular matrices is lower triangular. And product of L1 into L2 is also lower triangular. So this is an LU decomposition. You can easily do decomposition. You can I'll give you an assignment where you will do this decomposition yourself. But you can show this as homework, that the product of lower triangular matrices is lower triangular. This is your homework, okay?
আচ্ছা আরেকটা জিনিস মৈনাক দা, the same applies for upper triangular ones, right?
Correct. Yes.
So,
Also applies for upper triangular ones. Now, is it clear?
আচ্ছা
Okay,
ওখানে
so with
ওপরে
two
যে
things we did here. কি ওপরে?
ওপরে কি তুমি এটা কি দেখালে না, that that E1 E2 up to En some U, that can you please show please that part?
Please go back last day's class O3. Do you remember that we did it in last day? Multiple eliminations.
Yes.
We'll do
Gauss
today also.
Jordan,
Now
that one too.
Gauss-Jordan elimination. So that can be written as we saw just now, multiplication of elimination matrices. Yes or no?
Yes.
Yes.
Let's do this. You will understand. Go back and see if you have not seen last day's video. It's not there for no reason. Okay. I just wrote in bigger fonts. We'll have become smaller other things. Okay. So now I have this matrix. Right? So do you agree that EA also will have the same column space, same null space? Right? Do you agree they will have the same null space or not? We showed, right? AX is equal to 0 means EAX is equal to 0 also.
Yeah, so A and EA have the same null space, yeah.
So now I can keep on doing elimination. So this is one pivot. Okay. Now when I get 0 in a pivot, I go to the right if there are elements below it. So 3 I have, 3 is present. Right? If there is no element, so what do you do?
If
The rule is, wait, if there are no non-zero elements below diagonal, you go right. So you will go right if 3 did not exist and you had 0 instead. Okay. Then you would not be able to do any. Correct?
Yes.
So if they do exist,
then I'll shift up.
then I will do a permutation. Again, permutation matrices also PAE of X will still be 0, right? Doesn't matter if I change rows because I'm taking the linear combination of the columns, right?
এক সেকেন্ড প্লিজ, মানে আমি যেটা বলছিলাম সেটা হচ্ছে যে তুমি পারমিউটেশন ম্যাট্রিক্স মানে কি?
I'll just permute the rows. That's what this means. 0, 3, 5, 7. And I'll shift these two downwards. Okay.
Can you show the
row
form
swapping,
of permutation matrix?
I will show it's in your homework question also. I thought I will not show it in class. You'll learn it in your homework, but let's see.
Oh, okay, then I will try.
No, you tell me. It's a very simple thing. You only can tell me. So if I have, did you understand the rule? Step one is remove everything below, right? Remove
Yes.
everything below. Step 2 is move diagonally. if 0, two cases. One, if all elements below it 0, then move right with the pivot. With pivot and continue. Continue. Good that you ask. Then, now tell me, now your homework problem is solved. Shit. Else, what will you do?
Else we will shift the rows.
Shift
So to bring a non-zero element in
the row
that
where there is
pivot
non-zero
position.
element. There is non-zero element. Now tell me, how will I get that? How will I transfer this? What what permutation matrix should I use? You will tell me. I will have to multiply to the left, right? If I multiply to the left, row space does not change, correct? And null space does not change, right?
Yes.
So now tell me, how will I convert? Like R1 has to be in R1 after the permutation. So what will be the first row? Array, R1 is in R1. R2 will be R4. R3 will be R2. R4 will be R3. This is all you need, right? Partho, you tell me. What will be the matrix? It's exactly like a
Well,
permutation. Tell, oh, please tell.
yes,
Means basically that I will locate the non-zero row
No,
and
no,
I
I
will
want. Yes, first tell me the answer. First row you tell me. I know the how to do. I have already shown
yeah,
that.
it's gonna be 0, 3, 5, 7
Cool.
in
No,
the
no, no.
second row.
I have to multiply P1, P1 and get this A2. So I have to find this P. What will be the P? Tell me the first row. Then O3 will tell me the second row.
What's gonna acha how to transform oh right, it is first row is 1 0 0 0 0.
Bas, done. Keep quiet now. Second row, O3.
like it will be 0 0 0 1.
Good. Brahmajit, third row. If you can hear me. Third row has to be 0 0 0 2. And I'm taking the row 2 of the previous matrix. So it will be 0 1 0 0, right? And the fourth row, O3, or Partho, tell me fourth row. O3 has already told me an important row. Hello,
So
Partho?
tell
Tell.
0 0 1 0.
Good. So this is how you get this matrix. Now what will you do? You will convert this to, again, this is a pivot now, right? Right or wrong? Till
Yes.
now you have done two operations, E1, P1 of A, right? This is what you have done to give you
Yes.
A2. Now what will I do, Otrish, tell me? So I've got two pivots.
Like no more necessary steps are required for this pivot. So we can
Okay.
set E2 equals to I and then move on to 2.
Okay. 1 7 2. And I will just subtract from the column and I'll make it 0, right? Just subtracting. R4 is equal to R4 minus R3. So now you see the last row becomes 0, yes or no?
Yes.
Which shows that there is a dependent column or a dependent row. If there is a dependent row, there is also a dependent column. Dependent column. You can see this. We'll see this just now. Remember, number of dependent rows will be equal to the number of dependent columns. So now you tell me how many pivots do you have? Number of pivots? Once every, now you cannot go get any more pivot, right?
Yes.
So now how many pivots do you have?
3.
3. So this is known as the rank of A. Okay. Number of pivots is equal to rank. So we found number of pivots is equal to rank of a matrix. Right?
Acha, Moinakda, can you show me that if all elements below are 0, then move right with pivot and continue? মানে আমি না এটার মানেটা ঠিক বুঝতে পারলাম না, একবার আমাকে দেখিয়ে দেবে একটু।
আরে এইটা 0 হলেই 2 এ যেতে হতো।
হ্যাঁ,
if this 3 was 0 somehow,
if the 3 was 0 somehow, yes,
then you would have started from this 2. I've written this now. If the 3 did not exist, it was 0.
acha,
then permutation would not have helped me.
yes, then I would have shifted to 2.
Yes.
And then taking 2 again as the pivot, I iterated again.
Yes.
Fine.
Keep doing questions. I will give you homework also, and then I thought I'll not give you a homework to do this. You'll write a code, but I think now I have to give. Good. So now what is the?
Is this move diagonally if it is non-zero?
Whenever you can do row operations, you can to move diagonally. That's the idea. Only you have to move diagonally. When it is not possible to move diagonally, you move to the right.
No,
You
so
see,
why not possible to move diagonally?
if it is the, in this case, say you have a matrix like this. Now move diagonally and tell me how will you move? What is the rank of this matrix? First tell me.
Number of it's 1.
1. This is why you are getting 1 as answer. Now, rank is equal to number of pivots is equal to dimension of column space.
Oh, then
or is it number of independent columns. So you have 1 column and 2 column. 2 independent columns you have. So now
yes.
if it is already 0, where will you go diagonally? It will still have two pivots.
If it is already 0, then where will I go diagonal? Oh, acha, yes.
0 cannot be a pivot. Pivot is anything that you can multiply and make everything below it 0.
Yes, yes, because 0 to itself 0.
So the number of pivots is equal to the rank of A is equal to the column space dimension. Okay. Now let me see. I'll do this and end for today. Give me 5 minutes. So what will be the dimension of your column space, Otrich?
For this example, this will be 3.
What is the dimension of row space here?
Also 3.
Good. So dimension of row space is always equal to dimension of column space is equal to rank of a matrix. I'll come back to making it equal in because it is 3 because you have already got 0, right? Yes or no? And by
Yes.
just doing linear combination of rows, you have got 0, right? You have only done linear combination of rows. So these three are independent rows. You agree? So by construction, number of pivots is always equal to the column space dimension is equal to number of row space dimension, and that is equal to rank. This is the most important theorem. You have another theorem. So number of pivots plus number of non-pivots has to be equal to what?
Equals to number of columns.
N.
N, yes.
Right? Number of columns also is equal to number of rows if you define the pivots accordingly, number of non-pivots accordingly, right? Here non-pivots, I am doing dependent columns.
Oh, Moinakda, are you trying to approach at the rank-nullity theorem?
So this is what happens when you learn theorems. I just don't know the name of theorems. I'll just give you I'll derive it. What is the number of pivots then? We have shown this is equal to rank, yes or no? Is it visible?
Yes.
Yeah, it is rank.
Yes. Is equal to n is also visible, number of columns. But I don't know dimension of number of non-pivots. I don't know, right? I don't know
Yes.
number of non-pivots. Not known. What is it? Not known. Now let us find out what is this. And then we'll stop for today. This solves our 4 or 5 questions together. And we can just start with another method next time. Okay, so let us see. So now you tell me, I know so if I am told to find basis of column space, what will I do?
Basis of column space.
Yes, Godrej will tell me. Tell me, Godrej.
So like we can reduce to using this elimination.
We can, but good. But you need not use elimination. You can tell me in terms of the initial matrix only, because you have already got the columns in which you have pivots. Wherever you have pivots, they are independent. Agreed or not? Because you could not make them 0.
Yes.
Wherever pivots are there. So tell me in the initial matrix, what are there? The column 1, column 2, and column 3, right? What were there?
Acha,
1 2 5 1.
Why are we taking the columns from the initial matrix?
They are same, Ray. Initial matrix is what we are trying to address, right?
Yeah, so means since after transforming we observed that these are linearly independent, so I can say that in the initial matrix also they were linearly independent.
Yes, of course.
Okay, fine.
Number of independent columns will be, so your basis can change when you do row operations. That's why I don't want to do that. I want to write in terms of the initial matrix. 1 2 2 5, 1 2 2 5 4. And what else? 1 4 7 8. 1 4 7 6. Right? These are yours. 1 4 7 6. Agreed? These are the 3 column space bases. You can make the column space with these 3 vectors. Now I want to also show the null space. How do I do that? So I have this matrix with me. 1 0 0 0 1 3 0 0 1 5 2 0 and 1 7 2 0. This is my matrix new. Agreed? And I know that its null space of matrix new is same as null space of batao.
Null space of matrix A, the initial.
Correct, because we have done only row operations and row operations don't change the null space. We have shown that.
Yes.
So now I want to do more row operations to help me.
So do row
Can you-
operations change the column space either?
Of
No.
course. Of course it will change. Column space you are saying. Column space, we are taking linear combinations of the rows. X belongs to, no, it will not change. So you can also write
Yes.
this as, you can write this also as your basis vectors, not a different, not a difficulty.
চেঞ্জ হচ্ছে মনে হয় রো স্পেসটা না?
Row space is changing because you're taking linear combination of the rows, right? By definition,
হ্যাঁ
it's changing.
obviously. বুঝতে পেরেছি।
Yeah. So now, how will I? Utrij, we did Jordan elimination last time, right? Do you remember?
Yes. Yes.
So now, if I have to do Jordan elimination, how will I do the Jordan elimination? Is my question. So my above my pivots also, I have to make it 0. Yes or no?
Yes.
So first step, which one will I do? I have to make these two 0 as my first step.
Means you are completely neglecting the fourth column.
Yes, wherever there is no pivot, I will neglect.
Acha, okay. Okay, then then.
So I will do 0 2 0 0, right? What will the other rows become?
There will be no change in first and second column, and fourth
Good.
column will change.
Fourth column will change. How will it change? Now, Partho, tell me. So I am doing R2 as R2 minus 5 by 2 into R3, right? This is what I'm doing.
Yes.
Yes or no? And I'm doing R1 as R1 minus 1 by 2 into R3. Yes or no? Right?
And I'm doing
Yeah.
R1 as, oh acha, हाँ. R1 as R1 minus half R3. Yes.
R1 minus 1 by 2 R3. I will put everything above the diagonal also 0. Okay.
Hmm.
Then tell me if it is then tell me what is the third column, fourth column values.
9 by 2 will be above 2.
9 by 2.
No, মানে 7 minus R2 minus no. 5 by it will be 2 in that 2
2. Then
above 2 and that will be বলছি minus half
first one.
R3. That will be 0.
Array 1, both are 1, both are 2. Good. Now tell what is left to be done.
উপরের একটা
Or 3.
So what will be the next step?
R1 is equal to R1 minus 1 by 3 R2.
0 3 0 0 0 0 2 0 and what please tell me what will become the first column?
It will
Minus
become
2 by
minus
3.
2 by 3.
Now I am still not done. I want ones only in the diagonals. What will I do?
Take
I want only ones in the pivot.
take common 3 and 2. Take
Good. I will just
common 1, 3 and 2.
make this 1 and it by 2 by 3, and this will be 1, and this will be 1, right? Yes or no?
Yes.
Now you see, I have this form. I have identity matrix, some extra matrix F, and I have a 0 in below. Yes or no? This form I have.
Yes.
This is also called as a block matrix. I'm writing in terms of block matrix. Okay. So I some identity matrix I have, some F matrix I have. So these, wherever there is identity matrix, this is a, what are these? Independent columns, yes or no?
Yes,
These are my
identity
independent.
matrix independent columns. Yes. Yes.
O3 understood? They are independent columns. Because
Yes.
we had that wherever it was independent, pivots were there, that only we converted to identity, right? Pivots were converted to this. Correct?
Yes.
And this is my dependent matrix. Why is it dependent? Let me just show you. If I multiply this with minus f comma I, what will I get? Minus f comma I.
I'll get null matrix.
So minus f into I plus I into f is equal to 0. So this is in the null space, in null space of A, right? So we
Yes.
showed that number of non-pivots is equal to, by construction, null space of A, right? Yes or no?
না,
Three understood?
এই নাম্বার অফ, না আমি এই জায়গাটা বুঝলাম না, তুমি কি কিভাবে বললে যে নাম্বার অফ নন পিভটস নাল স্পেস হবে?
How many columns are there? How many columns are there in F here?
If how many column? One column.
One column is there. I am saying number of columns in F is equal to the null space dimension. I'll show
Number
you
of
why.
columns is equals to-
Don't like do wow, what happened? What happened? I'm showing. Wait. Look at this. Do you see the column null space of A is in this form minus f comma I? Do you agree?
minus.
We
Yes,
just showed
yes.
now this minus
Yes.
f into this. So now minus f, you will just put the values of minus f. Put it. So wherever there is f, put in the identity place, you will put the values of f. And in the f's place, you will put identity. Right?
Now,
Yes or no?
can you please put it once and show?
How many? What is the dimension of IO3? Here in this case, 3 cross 3, right?
Yes. 3.
What is the dimension of identity? Is always 1. We can express with one number. What is the dimension of F?
1.
Even
3 comma 1.
3 cross 1.
Yes or no?
Yes.
So you
Yes.
have 3 numbers here, and you can put those 3 numbers into 3 placeholders in I. Yes or no? Just see.
3
Let us do this. See this. Look at this column. I'll just take this column, pick this up, right?
Yes.
And I'll place it directly here. Put it with a minus sign. 2 by 3, 2 by 3, minus 1.
না ওটা
হ্যাঁ।
-2/3 হবে না?
Minus 2 by 3, minus 1, and 1.
And 1.
So 1 is because I wrote 1 null space. Identity.
Oh, acha. Identity matrix of dimension 1. That is 1.
Yes.
Ah, okay.
So your null space of A will be alpha into 2 by 3 -2/3 -1 1, right?
আচ্ছা একটা জিনিস I'm not understanding. You
I
told
will
that I will show you.
don't stop me. I will come to it and you will understand. Just wait for 1 minute. Just multiply this with this matrix once and see if it is giving me the right answer. See. Just check if it is giving me right answer. Is it giving me right answer? For the first 2 rows, it is trivial, right? It is true. First 3 rows, right?
Yes.
Let me just write it down. 2/3. Or let me just multiply 3 into it and see. 2 - 2 - 3, 3, right? Just tell me first row, what will it be? Since they are all ones, they'll become 0, right?
0.
2 1 2 5 1 plus -2 1 2 5 4 plus -3 1 4 7 6 plus 3 1 4 7 6, right? Which is equal to 0 0 0. And the fourth column is 2 -8 -18 plus 24, right? Yes or no?
Yes.
Is it 0? Okay, is it okay?
Yes, it's okay.
Otrich?
Yes.
So you understood how to get the null space. So if you now I'll just show you. Let me just finish the proof of this. So number of non-pivots is your number of dependent columns is equal to the null space, dimension of null space. I'll show you why. But therefore the theorem is dimension of column space of A plus dimension of null space of A, or rather rank of A. Don't write column space, it's not right. Rank of A plus dimension of null space of A is equal to n, right? Now you ask the question
Yes.
that you were asking.
Yes,
Tell me.
actually, null space, what I'm seeing is that whenever you get a single vector, means whenever you obtain a single vector for which
Now, okay,
it is
okay, everything is
0.
okay. Now wait for 1 minute. It will be solved by this question. If I have after row reduced echelon form, I get this matrix. Otrich, just tell me, or you, Partho, just tell me what will this be? I have this, right? Okay. And I have 2, 4, 6, -9. Okay. So tell me which is I
Yes.
and which is L. Which is I, which is F.
Uh,
This is my new matrix. So
yes.
say B matrix.
Hmm.
So what is the column spaces at this? Column space of B?
Column space of B.
Column space of B is these two I'm saying.
Yes. Yes. Yes.
These
Yes.
two columns. I have it in form of I, F. Right? So my now rank is equal to 2, right?
Rank 2, yes, number of pivot
What is the
elements.
dimension of, you should be able to tell me what is the dimension of null space? 2?
2
N
or
is
4
equal to
minus
4.
2.
No, not like that. These two are the null space vectors. Like will help me to get the null space vector. They are not the null space vectors. But tell me, how will I get the null space now? Please tell me, how will I get the null space? Null
Like
space of B? Yeah. Remember always minus F, I is the form. This is why you are going to get more than one vectors here. Tell me, Utrecht, and tell me, Partho. Tell me one vector, you tell me one vector, you tell me one vector. So what is the dimension of F here?
2 cross 2.
2 cross 2. What is the dimension of I?
Same 2 cross 2.
So your F has to be replaced by, so you have
Minus
to
F.
get 2. So -2 -4, yes or no?
Yes.
So first I will take this column. This is one option, right?
-2. Yes, yes, yes.
And other
Minus
option is
2.
and similarly for respect to this, what will I fill up?
-6 9.
No, this F I have put in I's position. Look at this. This is F, right?
Yes.
Wherever there is I will put the F corresponding to it, because I minus F corresponding to it.
Acha.
This has to be two-dimensional. This has to be two-dimensional. Wherever there is F, there I have to put I.
Yes.
Right? Wherever there is I, I'll have to put F. So what will be the value of I here? 1, 0. This column I will take. Whichever column you are taking, corresponding column you will be taking for I as well.
Whichever column I'm taking, corresponding column I'm taking for I as well. Okay.
Just see,
Yes.
you'll understand. 6, 9 minus 6, 9, 0, 1.
Yes.
So all combinations of these two will be your null space. Let us check. 1, 0, 0, 1. 0, 0, 2, 4, 6, minus 9, 0, 0. Just put this vector -2, -4, 1, 0. What will this be? Otresh, tell me. Tell me. This multiplication you cannot tell me.
Yes.
Well, -2 into 1, 0, 0 plus -4 into
Minus
0,
4
1,
into
0.
0, 1, 0. Yes. 1 into 2,
1
4,
in
0.
plus 0. Is this 0 or not?
Yes, yes. Yes.
See, look at this block matrix I and F. And I'll stop here. If I use this block matrix and multiply -F and I, am I getting 0 and not? You have to just put the values
Yes.
like elementary algebra. Like multiply normally, na? How did we do it? Normally, how do we multiply? This F into I plus F into I. Yes or no?
Yes.
I should put the I on the left. So see, where did we see this third column I have put, right? In the first two case. So first two have to be F, right? First two first two by 1, first two elements have to be elements from F. Agreed or not?
Yes, yes.
So I have which column am I taking? I'm taking the third column, right?
Yes.
Good. So if I'm taking the third column, which of the i's must I take? So if I am taking the third column, in this third column, I have to also take the 1 in the third column. Yes or no? This is why I wrote 1 in the third column. Understood?
Yes, yes, yes.
I have taken the fourth column here, so I have taken the 1 in the fourth column. and whatever will be left will be put with zeros in the dependent vector, in the independent vector. Okay. There's a simpler way, but this is efficient to understand things. We'll see the simpler way next class. Or is this clear? I'll give you a homework. Please share this and share it in student discussion. Why did you upload it in the group? I'll do this homework for me. 1 4 5 6 0 0 0 0 1 0 0 0 0 0 1 0 0 0 0 0 -9. Array, why am I writing -9 always? -5 0 -3. This is your C matrix. Okay. Now I have given you a bit of a trickier thing. Why? Why
Because
is it trickier?
all I is not on one side.
It's not together. So please go back. But you can also always think of it as together. You can
Yeah,
like group
because I
this.
can multiply it by a permutation matrix, right?
Not really. Permutation, it has to be a column permutation in this case. Column permutations are not, that is not right. But you can think of it that way. So here the column 1 is there, column 2, 3 is there, column 4 is there. So you can say I belongs to 1, 3, 4, and F belongs to 2, 4. And accordingly, make your matrices, right? How many dimension will be your null space, first of all?
How
1,
many
2.
dimension will be my null space?
What is the rank?
6.
6. Oh, you're saying 6. Correct. Right. You're right. 1, 2, 5 you mean, right? You mean right. 5, you're right. 3, 4, 5টা আছে তো, 5টা কলম আছে তো। 32?
হ্যাঁ 5.
2 and 5. Right, so it will be belong, null space of C will belong to R5, but how many dimension will be RC? From the Rank-Nullity theorem? How many pivots are there?
2, it's gonna be 2.
I am asking how many pivots is 3.
3.
So dimension of null space of C is equal to 5 minus 3 is equal to 2. Right? Agreed?
Yes.
So now,
Yes.
whenever you will be choosing this second column, right? You choose, that is this column. You will choose the appropriate values where to put the ones, right? 1, 0. Similarly, that is 2 will become 1 and 5 will become 0 and so on, like that, right? Just try this out. Find this null space. Null space. Okay, with that we can stop. So it will be 2-dimensional and you have to find the total 2-dimensional null space. But with that, let me just end with giving you one recall. So we have wasted a lot of, I don't know how will I. This has been, share it in a different folder maybe. Otherwise this will become too small. Okay, so before we stop, in this figure, tell me what is the dimension of the column space then?
M.
M, so it is a subset of the M. We showed now by construction what is the dimension of A, which is the AX is in the subset of M. Go back and see it once again. Ax is in the subset of M. Therefore, column space is, we sure it is equal to number of pivots, right?
Yes, yes.
Yes, it is
That is
equal to rank.
rank of A. So what is the dimension of row space? We also saw that.
Also rank.
Yes, again, rank of.
Equal to R. So what will be the dimension of null space of A transpose them?
Number of columns minus rank A.
No,
M minus M. Yes.
because both of these two are subspace of Rm and they are spanning the entire subspace. We will see last time why they are perpendicular also. They are a direct sum. It will be M minus R and that will be N minus R. We'll see next day.
They are spanning the entire subspace. এটা তো ওখান থেকেই বলতে পারি যে dimension of
Correct.
CA plus RA, dimension of CA plus dimension of RA.
Correct. From the they're spanning the entire subspace and also they are perpendicular. We will see that next day. So they are spanning the entire space because why, Partho? Why, Otrich?
Yes,
Why is it spanning the entire subspace of M?
because
This will be the dimension. So when we did row reduce echelon form, we had zeros at the bottom, or yes or no?
yes,
Correct. So and we had R columns, right? R rows. Yes or no?
yes, sir.
So there are R independent rows, yes or no?
Yes,
So what is the rank of the row space? Tell me.
rank is R.
R. Good. Then what is the rank of the column space?
It will be also R.
R, yes, column space, no, null space. I mean,
Null space is M minus R.
yes,
Dependent
these are
vectors.
the. We will see how to use this row reduced echelon form just by multiplication elimination to get the same matrices next class. So by construction, they are independent. They span the entire Rm and Rn. They are perpendicular. We'll see it next class, and we'll see one way to show that we can use elimination to directly get the null space and the row space, which you will be using in your homework assignment to code that. So with that, I'll stop recording, and if I have questions, I'll take it offline now.